So, we were discussing about theta, but in the last few slides in the last class we had discussed what is delta. Delta was rate of change of the portfolio with respect to stock price. Then was gamma, gamma was the second derivative. Then we had basically vega, vega was the rate of change of that portfolio with respect to standard deviation. Now we are considering theta, which is the change of the portfolio with respect to passage of time. So, this is also called the time decay of the portfolio. Theta is usually negative for an option, as we have discussed, because as it comes to with all things remaining constant, the option will generally tend to be less valuable as time approaches comes to decay to its expiration. Rho is the value of the portfolio, which is the rate of change of the value of the portfolio with respect to the level of interest rate. So, initially again I am repeating, first one was respect to spot price, second was also with respect to spot price was the second derivative, then was with respect to standard deviation, then was respect to the time, now is respect to the interest rate. So, if you have a currency rate option, then we have two interest rates, one for the domestic currency and another for the foreign country. So, if you remember the domestic and the foreign currency with respect to the swap was R and R star, and based on that we basically formulated different swaps. So, here also rho would be the rate of change of the change of the value of the portfolio with respect to interest rate. Now, in general, if we consider all these 5 or 6 rate of change, then how would we express the rate of change of the portfolio in totality? So, if we check the rate of change of the portfolio, it will be with respect to the rate of change of the portfolio with respect to spot price, which was basically the first one was the delta. Then we considered this is the second one, which was the basically the gamma. Then if we consider that we had the vega, then we considered if we had the respect to that time, and then we considered we had with respect to the interest rate. Interest rate I have not drawn it here, let me check. No, I have not shown interest rate. So, basically it can be the interest rate also can be brought. So, if you see this is the rate of change of the portfolio with respect to spot price multiplied by the quantum change. This is the rate of change of the portfolio with respect to time multiplied by the quantum change, means quantum change of that variable. Rate of change with respect to standard deviation into the quantum chain. This is the second derivative. This is basically the second derivative. This is the second derivative, but the second derivatives are with respect to spot price, with respect to time, with respect to standard deviation. This is basically again the second derivative, but being second derivative being taken two different times by two different variables. First with respect to spot, then with respect to time. It could also have been with respect to time and then spot. This is with respect to spot and standard deviation. It could also have been with respect to the standard deviation and the spot, then again with respect to standard deviation and time, and it could also have been with respect to time and the standard deviation. Now, if you see this should remind you of a very famous equation or expansion which we have done in class, maybe in class 11 or 12. This is known as the Taylor series expansion, but here the Taylor series expansion is the multivariate case. Now, if you consider, so I will continue the discussion of finance later on, but first let us take a deviation and considering the multivariate deviation. The first the univariate Taylor series expansion, then expand it to the multivariate one. So, if f x was the function and I want to find its change f x at naught, this would be given by the derivative of this function with respect to x naught with h by factorial 1, where h is technically given by x minus x naught. Then you have basically f double prime x at x naught into h square by factorial 2 and continue still. Now, if I consider, so this is the univariate case, remember. So, now to draw the multivariate con. So, let us delete this. So, let me delete this also. So, it will be easier for me to scribble on this slide. Yes. Now, for the multivariate case, what you will have, again I am drawing f of x. Now, x is now a vector, not a scalar. This x naught sorry, x naught is also for the case where it is a vector. So, x naught is this, the first variable 0 value, second variable 0 value, and so on and so forth. This would be equal to the rate of f of x with respect to x1 is the first variable plus all the other variables till x k, and the next one would be, so these are all the first derivatives with respect to h 1 and h k, where h I is equal to x I minus x I 0. So, these are the h k's, and the next one would be basically second derivative with respect to h I h square factorial 2, and they would be k number of times. So, h are different. In the first case, when x 1 is 1, it will be x 1 minus x 1 naught. Second case, when it is x 2, it will be x 2 minus x naught, and so on and so forth. Now, here the overall terms are not finished, because if you see, the second derivatives can be taken also in this respect. So, this would remain, this part which I am just highlighting. So, for the time being, consider this is already there, as I do not have space, hence I am writing. So, this would be, let me delete this also. So, this is already there, consider it is written, but let me delete it. So, the second term would now continue is del 2 f del x I del x j h I h j factorial 2. Now, this x I and j are the terms, say for example, x 1 x 2 or x 1 x 3 or x 1 x 4 and so on and so forth. And this h 1 I and h j are, say for example, h 1 and h 2, where h 1 would be x 1 minus x 1 naught and h 2 would be x 2 minus x 2 naught, or else h 1 h 3 would be x 1 minus x 1 naught into x 3 minus x 3 naught, and so on and so forth. So, if you consider these terms are this. So, that means, if you take in either sense like x 1 x 3 or x 3 x 1, in this case they would be repeated twice. Hence, in order to take into that interaction, you are taking the value would be 2, but we are basically ignoring it, because if there is 2 here, this 2 will cancel, hence there is no 2 coming here. But if we consider only the first terms, there is factorial 2, this factorial 2s are this. So, if you do the simple multivariate Taylor expansion, this is the answer which you get. So, you can find it in any simple textbook. This I thought I will just make you clear. Let me delete it and then continue discussing. So, knowing the terms gives us the full value of the expected value of the rate of change of the portfolio and variance of the portfolio, which is required to find out the overall risk of the portfolio, which we are going to consider in 1 or 2 classes. Now, we will just not change the overall discussion of quantitative finance, but we will go into a different topic, which is known about the rating agencies. Rating agencies, how they do the rating, what are different type of concepts which are doing by the rating agencies. So, it will be much more less theoretical, but it will give you a good flavor that how the rating agencies do their work in very general sense. So, what are the rating agencies we know? We have heard the name of Standard and Poor's, we have heard the name of Moody's, we have heard the name in India, we have the CRISIL, in India we have the ICRA, and so on and so forth. So, these are the rating agencies about which we will very briefly study. So, they specialize in evaluating the creditworthiness of corporates, municipal bonds and sovereign issuers, or some type of portfolios or financial portfolio which has been formed. It is their job to inform the investors about the likelihood that the investors would receive the principal amount plus an interest rate payment as scheduled, depending on the overall change of the risk. Basically, the rating agencies find the probability of default by these corporates, etc., in order to inform the investors about the overall level of risk the investors are facing. In US, bond trading agencies evolved from the firms that evaluated the creditworthiness of merchants And Robert Dunn and John Bradstreet were among the 19th century pioneers in this business, and their companies ultimately merged in 1933 to form the company Dunn and Bradstreet, which we have already heard and we know. In general, if you read the papers, if you read history, finance, it is historical development. If you check any good book, you will find all these details there. In the first decade of the last century, John Moody's extended the credit rating concept to securities, focusing first on railway bonds and soon on utility and industrial bonds. ICRA was promoted by the leading financial institutions and banks of India and was formed in the 16th January 1991. From September 1, Moody's is the largest shareholder in ICRA, and for CRISIL it is S&P. Credit rating norms had been successfully developed by the two most celebrated rating companies, one is the Moody's and one is the Standard & Poor's. In India, we have the CRISIL, formerly the Credit Rating Information Services of India, and now S&P company. ICRA, formerly Investment Information and Credit Rating Agency, is now Moody's a company. In US, you have the Duff & Phillips, Fitch and IPCA, Standard & Poor's, Moody's. Now, Moody's is the subsidiary of Dun & Bradstreet, and Standard & Poor's is a division of McGraw-Hill. McGraw-Hill is the publication big company which you all know. So, the symbols, first let us go through the symbols and then I will come to the actual details of how the analysis is done in a mathematical sense. So, if there are different ratings which are given, if it is AAA, AA plus, AA minus on the first column, then and so they are basically corresponding to the S&P. And the corresponding symbols which are being used for the Moody's are also AAA, but A, capital A and then 2 small a's in place of 3 capital A's. Then you have AA plus, it is basically AA1, then AA2 and so on and so forth. But in general, the characteristics which they portray are almost the same, exactly the same. If you interpret it in the qualitative sense, the first block would be the highest quality, extremely strong, and the less likely default. Then you have the high quality, where the default level has slightly increased. Then you have the strong payment capability, where the default is still there and is slowly increasing. Then you have adequate payment capacity, where now the concept of default has really increased. And if you consider again continuing that, you have the S&P and the Moody's again in the first and the second column given by BB plus, or correspondingly it is BA1, then BB, or which is BA2, so on and so forth. Then it goes to CCC plus for S&P, it goes to CAA1 for Moody's, and the last one which you have in the S&P is CCC, CCC minus, double D, and the corresponding things are CAA2, CAA3 and CA. If you see the interpretation, basically now here the level of confidence is decreasing, level of risk is increasing. So, and that means likely to fulfill obligation and ongoing uncertainty is increasing. Then it becomes highly risk obligations are there, hence the level of default has really increased. There is current vulnerability to default, hence the probability of failure has an increase, and the last case there is a bankruptcy, which means everything which has been invested in that type of companies may with a high probability, almost 100% probability will fail. So, the rating process, how it is done, I will give you a very qualitative feel without going into the details, because all these things are under the purview of accounting concepts. So, if you understand the accounting concept very clearly, then understanding these concepts in the sense that how the rating agency utilize those using the fundamental analysis of the characteristics of the company. If you remember, I had mentioned that fundamental analysis is one of the principal characteristics to understand the actual fundamental principle based on which how the company is performing, and the fundamental concept would actually give you the information of how the stock market is doing. And I did mention also that there is another area of study which is basically studying of charts, which is known as technical analysis, which we would not consider. So, our discussion was going on in the area of credit rating. So, if you remember, we were just in few minutes back we were mentioning about different types of risk corresponding to different levels of ratings. So, it can be AA, AAA, CC, CCC, whatever it was. So, now what is important to know is that we did mention in one of the classes before fleetingly, and we will definitely mention in more details. What is needed is basically how do those risks project or they change from set 1 to set 2. Set 1 to set 2 means that how do they change from, say for example, from AA to BB or BB to CCC and so on and so forth. What is important is to note that given the distribution or given the probability at any one stage, we want to find out what is the conditional probability that will change from stage 1 to stage 2. So, this is a big branch of studies in the area of, say for example, credit ratings. We would not be going into details, but we will still cover the concept of hypothesis in a very simple way and how the transition probabilities are done in the later classes. So, with this I will try to end this class today and continue the discussions of credit rating and other things in later on. Thank you.